the area of the region of a point P which is such that it is satisfying two conditions. What is the first inequality it is satisfying? PA plus PB is less than 2, and the second condition it is satisfying is PB plus PC is less than 2, where the points A, B, C are fixed and given to be A as 1 by 2, 0, B as 3 by 2, 0, and C as 5 by 2, 0. Now, first let us identify what is the region defined by PA plus PB is less than 2. Clearly, PA plus PB less than 2 is the region which is inside an ellipse, because PA plus PB equal to 2 would give us the ellipse equation whose foci are A and B. So when we write PA plus PB is less than 2, then P lies inside the ellipse with foci at A 1 by 2, 0 and B 3 by 2, 0. Right? So how will be the region which is inside the ellipse? This is an ellipse having their foci at A and at B. Now, how will be the second equation? The condition that PB plus PC should be less than 2, then P will be a point which is inside another ellipse whose foci are B and C, that is B 3 by 2, 0 and C 5 by 2, 0. So how will be the second ellipse now? It will be another ellipse having foci at B and a point C which is 5 by 2, 0. Now what is the region required? A point P which satisfies both inside of the first ellipse as well as inside of the second ellipse. So what we need to evaluate is the area common to both the ellipses. Now if you observe these ellipse equations, the area, a part of it is covered by the second ellipse and the remaining part is covered by the first ellipse. So when we consider a partition here, then let's mark these points also where the region is bounded. Then this is T, this point is E. Let's call these 2 points as Q and R. So area of the required region, that is the total shaded region, is nothing but the region of T, Q, E, R, D. That is the shaded portion of the curve. Now if you look at the symmetry of the curves, this will be 4 times the area of the region T, D, Q, E, D. That means we will try to evaluate only this area, and that would be bisymmetry multiplied by 4 times because all 4 regions are equal here. How do we calculate this portion of the area? This is the area bounded by second ellipse. The center would be 2, 0. So it is x minus 2 whole square by 1 plus y minus 0 whole square by 3 by 4 equal to 1. This will be the equation of the second ellipse. When expressed as a function of y, this is root 3 by 2 times square root of 1 minus of x minus 2 whole square. Between, what are the two limits of integration? The point D and the line QR. That is, what is the point D? This is the point where this ellipse cuts the x-axis. Where does this ellipse cut x-axis? When we put y equal to 0, we get x minus 2 whole square is 1, or x would be, when we put y equal to 0, then x minus 2 whole square is 1, or in turn x minus 2 is either plus 1 or minus 1. When it is plus 1, the point is 3, 0, that would give us the coordinates of E, and when it is minus 1, the point is 1, 0. So it is y equal to root 3 by 2 times square root of 1 minus x minus 2 whole square is x equal to 1. And what is this line QR? It's a line perpendicular to the axis of the ellipse, that is x-axis, and passing through the point B itself. So x equal to 3 by 2 with x-axis, right? So we know the limits and we know the curve equation also. So this can be evaluated directly. This is 4 times integral 1 to 3 by 2. The curve equation, that is root 3 by 2 times square root of 1 minus of x minus 2 whole square dx. So how much will be this? This is 2 root 3 constant coming outside. The integral of 1 minus of x minus 2 whole square, that is x minus 2 by 2 times the square root of 1 minus of x minus 2 whole square plus half times sine inverse of x minus 2 evaluated between the limits 1 and 3 by 2, right? Now we can substitute comfortably. We know the entire function and the limits. So this comes to square root of 3 times pi by 3 minus root 3 by 4 square units. So which option is it satisfying? The option presented D, which says the area is root 3 times pi by 3 minus root 3 by 4 square units. The whole problem is easy once we identify the equation of the required ellipse and the geometrically the region bounded by the points, right?